Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about difference between flexible pavement and rigid pavement. What is pavement? Pavement or carriageway is that part of the road or highway which supports the wheel loads imposed on it from traffic moving over it. It ought to be strong enough to resist the stresses that are being developed as a result of traffic. Pavement should also be thick enough to distribute the external loads on the earthen subgrade so that subgrade can safely bear these external loads. The pavement consists of a few layers of pavement materials over a prepared soil subgrade. Pavement consists of one or more layers. A simple classification of layers as per Indian practice is shown in as per below figure. The surfacing is the topmost layer, which should be smooth, abrasion resistant, dust proof, and strong. The base course immediately below the surfacing is a medium to distribute the stress evenly. The sub-base course gives additional help in distributing the stress. Subgrade is the compacted earth below the sub-base course. Pavement should be even. It should have light reflecting materials for night visibility. The layer surfacing is the topmost layer, which should be smooth, abrasion resistant, dust proof, and strong. The base course immediately below the surfacing is the medium to distribute the stress evenly. Sub-base, the base course that gives additional help in distributing the stress. Subgrade is the compacted earth below the sub-base course. Pavement should be even. It should have light reflecting materials for night visibility. Based on location, materials of construction, a fund available, necessity, use, traffic volume. Roads are classified into different types of roads like earth road, gravel road, water-bound macadam, WBM, road bituminous or blacktop road, and cement concrete road. Types of pavement. This is classified from the point of structural behavior as flexible pavement, rigid pavement, semi-rigid pavement, composite pavement, flexible pavement. Flexible pavements are such, which on the whole have minimal or low flexural strength and therefore are rather flexible at their structural action under the loads. The flexible pavement layers reflect this deformation of these lower layers onto the top layer of the layer. Therefore, if the lower layer of the pavement or soil subgrade is undulated, the flexible pavement surface also gets undulated. Flexible pavement consists of four components. Subgrade, prepared road bed. Sub-base course, base course, surface course. The flexible pavement layers transmit this vertical or compressive stresses to the lower layers by grain transfer through the points of contact at the granular structure. A. Well compacted. Granular. Structure consisting of strong graded aggregate, interlocked aggregate structure with or without binder materials, can move the compressive stresses through a wider area, and so forms a good flexible pavement layer. This load spreading ability of this layer, therefore, depends on the type of the mix design and the materials factors. Bituminous concrete is among the best flexible pavement layer materials. Other materials that fall under the group ARC, all granular materials without a bituminous binder, granular base, and sub-base coarse materials such as the water-bound macadam, crushed gravel, aggregate, soil aggregate mixes, etc. According to this, the flexible pavement might be constructed in many layers, and the top layer was the strongest as the highest compressive stresses should be sustained by this layer, along with the tear and wear as a result of the traffic. The lower layers have to take up only lesser magnitudes of stresses, and there's not any direct wearing action because of traffic loads. Therefore, inferior materials with lower cost can be used in the lower layers. The lowest layer is the prepared surface consisting of the local soil itself, called the subgrade. Rigid pavement. Rigid pavements are those that possess noteworthy flexural strength or flexural rigidity. The pressures aren't transferred from grain with the lower layers, as in the ease of flexible pavement layers. The rigid pavements are made with Portland cement concrete, either plain, reinforced or pre-stressed concrete. The plain cement concrete slabs are expected to take up roughly 40 kg square cm. Flexural stress. The rigid pavement has the slab action and is capable of transmitting the wheel load stresses through a wider area below. Semi-rigid pavement. When bonded materials like the pozzolanic concrete, lean cement concrete, or soil cement are used in the base course or sub-base course layer, the pavement layer has considerably higher flexural strength than the common flexible layers. However, these bonded materials do not possess as much flexural strength as the cement concrete pavements. Therefore, when this intermediate class of materials is used in the base or sub-base course layer of the pavements, are either designed on experience, or by using a new design approach. These semi-rigid pavement materials have a low resistance to impact and abrasion and therefore are usually provided with flexible pavement surface course. Composite pavement. A composite pavement consists of multiple structurally significant layers of different heterogeneous compositions. A typical example is a brick sandwiched concrete pavement. The top and bottom layers are of cement concrete, which sandwiches a brick clay in the neutral axis zone. Difference between rigid pavement and flexible pavement. Design of rigid pavement is based scientific design stresses of concrete on, whereas flexible pavement design is mostly empirical in nature. Life of rigid pavement is more than the flexible one. Maintenance of well-drained rigid pavement is practically very small, whereas the bituminous surface of flexible pavement needs frequent maintenance. The initial cost of rigid pavement is much more than the flexible one. Considering the stage of construction, flexible pavement is preferred to the rigid pavement. The selection of types of pavement depends on the availability of materials of construction. Surface characteristics play another role in the selection of types of pavement. A good cement surface is smooth, free from potholes and corrugations. Flexible pavement does not possess the above facilities. An impervious layer of the pavement is essential for the subgrade. Preference will always be the rigid pavement as concrete is impervious. Traffic dislocation during construction for about a month takes place as concrete requires a minimum of 28 days for curing and setting. In flexible pavement, traffic is allowed to move on the pavement once it is rolled. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.